I am going to quickly go through a few very simple examples where functions are used as first-class citizens. Now, before we get there, we just need to cover some very simple theory. Now, if we start with something like this, which is basically the simplest thing you can do in C#, I guess. When you look at this, what's happening is you are declaring a variable with the name A and type int and value 1. It has these three properties: name, type, value. We can do this, and we are allowed to do that because they have the same type. We can store A inside B, or we can assign A to B because they have the same type. Now, if we declare a function this function, or method as it's actually called in C#, but I will be using the word function. This function also has the same properties. It has a type. Now, the type of a function is a little bit tricky, but basically it's a combination of the parameters it receives and what it returns, or at least the types of the parameters it receives and the type of what it returns. So the type of this function is a function that receives an integer as a parameter and returns an integer as a result. That's the type of this function. It has a name as well. The name is add, and it has a value. The value is this. It's the payload. It's the actual code that gets executed. Now if we create another one, these two functions have the same type. They both take a single integer as a parameter and they return a single integer as a result. So they do have the same type. They don't have the same name. This one's name is add, this one's name is multiply, and also they do not have the same value. This one adds the parameter to itself and this one multiplies the parameter with itself. Okay. Now this is a lot like these two. Alright, let's do this. They also have the same type. They are both int. They don't have the same name and they don't have the same value, but we can do this because they do have the same type. So let's do this. There is another way to declare a function. You can do it like this. We are declaring a variable, but the type of this variable is a function that takes an int as a parameter and returns an int as a result. So clearly this variable has the same type as this function and this function, because these also take an int and returns an int, takes an int and returns an int. That is why we are allowed to take this add and store it inside this variable, because they have the same type. In the same way that we can store A inside B, because they have the same type. Now we can execute this holder variable by sending through a parameter. Now currently the value of this variable with the name holder is this, because we've added add into holder. We have assigned add to the holder variable. So if we call holder1, we are executing this code. If we do this, at this point, when we execute holder1, we are executing this code, because this is the value of holder at that point in time. Okay? So basically you can assign values to a variable if its type is a function that takes an int and returns an int. You're allowed to take this value and store it inside that variable because the type is the same. Okay, now there's another way to declare a function. You can declare it like this. So this is a lot like this, where you create a variable, it has a name, it has a type, and you immediately assign a value to it. In the same way that we assigned 1 to this value, this variable a, we assign this to the variable subtract. And because the types are the same, again, we are allowed to do this. Okay. Another way to define this is to just say this. It's the same thing, it's just a bit shorter. Okay, now let's go a little bit more complex. Let's create a function that returns an int. Call it executor because it will actually be executing code itself. Now, what is going on? In the same way that we sent through an integer as a parameter into the add function, we are now sending through a parameter with the name f1, but its type is this. So you are sending through a function as a parameter to another function, and we can return the result of it like so. So all this function does, it takes a function and executes it and returns the result. Now if we want to call this, I'm just going to clean this up. Oh no, let's not delete these two. No, hold on. Ah. So let's actually execute this. We send through subtract and a value. So if you run this, can see the value 0 is the output. So what is happening is we are executing this function, but we are sending subtract through as a parameter. We are allowed to do that because the types are the same. Right? So now, when this line of code gets executed, f1, which is this parameter, will have the value of subtract, which is this. And when we execute it, it will take this value as a parameter over here, subtract it from itself, resulting in 0. It will return that and store it in R1, which is just thrown out onto the console, and we can see it over there. Now we can just take add, execute the code, and now it's 4 because we are sending through this now, which is, it does have the same type. It's a little bit harder to see because we don't have this for add, but we can clearly see that it takes an integer parameter and returns an integer parameter. So that means it's the same type, and we can pass it through as a parameter. Now let's do something that's actually useful. Let's create a function that returns a list of integers. Call it filter. Now let's send through a function that takes an int, returns a boolean, and it also takes a list. Okay. Now what we can do is we can say, I'm just going to write it out as a for loop. You can use link, but I'm not sure if everyone understands link necessarily, so I'm just going to do it the long way. Okay. So this function takes another function which accepts a single int as a parameter and returns a boolean. It also accepts a list of integers. Now all it does is it goes through this list, and whenever this function returns true, it will be in the resulting list, and if it returns false, it will not be. So it's a filter, and we can use it like this. So let's call filter. Let's just create a function to pass through separately. Let's call it greater than 4. Okay. Actually, I'm going to change this and write it out just so that it's a little bit more old school and understandable. So we send through the filter function and the list. Add a breakpoint. Let's run it. Nope. messed something up. Oh, okay. I hope that's sufficient. It is not. What could not be found? This is wrong. Okay. Let's just store it. Otherwise, we won't be able to see the result. So now, this should only contain values that are greater than 4. Now let's step through it. We have a function. It's called greater than 4. It takes an integer as a parameter and it returns a boolean. If the parameter is greater than 4, it will return true, otherwise it will return false. We have this filter function that takes that a function as a parameter, and that function has to take an int as a parameter and return a boolean as a result. Another name for this type of function is a predicate. It's a function that returns a boolean. Now it also takes a list of int. It then just loops through the list and only returns values where this function, whatever it may be, returns true. Okay. Now there's a shorter way to do this. You can create something that has a type and a value, but it does not have a name. An example of that is over here. We can see there's a 1 there. It has a type, integer. It has a value, 1, but it technically doesn't have a name. It's just floating there and it gets assigned into A immediately, but it doesn't actually have a value, this bit. Only after it's been assigned into A can you say that A now has a value of 1, but on its own like this bit doesn't actually have a name. It's called anonymous, and we can create anonymous functions as well. So let's say we want to replace this GT4 over here with an anonymous function. We can do that. We can just say an int, a function that takes an int as a parameter, and then so it's shorthand. Now if you are familiar with LINQ, you might start noticing that this looks a lot like a where clause. Now obviously there are limitations, since this only works with integers, where a where clause in LINQ to objects work with anything. But we can solve this by changing this filter up a little bit. Now we can do this. If you know generics, this should be quite familiar to you. So now let's change the name as well. This is not the LINQ where, this is our where. Okay. Now you don't have to do this, but I'm just going to put it in there for clarity. Let's see if you get the same result. We don't, because I mucked something up. Name filter does not exist. Oh, obviously. It does indeed not exist. Okay. If you look at this list, we can see that it only contains values that are greater than 5. But what this generic bit does is we can now use this for anything. Okay, so let's create another list of strings. Doing something wrong, clearly. Not sure what though. It's this. It's something to do with this. Oh. Okay. Nope. You have to send through the correct type. Okay, so this filter works a little bit differently. It will only return values that is exactly equal to A, and as we can see, it filtered out the B. This B got filtered out. So this is this should start giving you some insight into how the guys who created LINQ managed to create the where clause, where you send through a function that does the filtering by returning a true or a false. So let's have an actual where clause just to compare. It looks like this, and we should be able to copy this exactly like this. No. Oh, that is because okay. So we have emulated the behavior of the LINQ where clause. Now it's not a great example, but it should give you a little bit of insight into how functions can be used as first-class citizens, where you can use functions in the same way that you use other traditional variables. Hopefully this will help you out a little bit. If you want me to cover any other topics, just leave a comment. I might decide to do that. Thanks for watching.